Welcome to our channel Team Basic Physics. Our today's problem is find the equivalent resistance of this auto. It is funny question, but it look like real auto. Okay, let's start solution. So first we duplicate this image, and if we see from this branch, suppose this is a point and we will find from this point. Okay, here is 2 ohm, so we will create an equivalent circuit. Here is 2 ohm. Now this 10 ohm is connected in parallel with a state wire, so the contribution of this 10 ohm is totally 0. Okay, then another 4 ohm, and again this 8 ohm is also connected in parallel with an 8 ohm. So the equivalent of 8 will be 8 by 2, means 4 ohm, and they are connected like this. This is A point and this is B point. Okay, now another branch from this A point. If it is A, it also A. Now from this one it is 2 ohm, so here is 2 ohm. Now we'll go through this. Here is 2 ohm and this 6 ohm is connected with a straight wire in parallel, so the contribution of this 6 ohm is 0, and this 2 ohm is connected with another 2 ohm and it is also connected with another 2 ohm. So 3 2 ohm resistance are connected in series, so the equivalent resistance will be 6 ohm. And also in the upper half another 6 ohm is there, so this 6 ohm and this 6 ohm are in parallel, so the equivalent resistance will be 3. Okay, now this one, here is 6 ohm and also here is also 6 ohm. These two 6 ohm are connected in parallel, so the contribution of these two 6 will be 3, because two 6 ohm are connected in parallel, so equivalent resistance will be 3. And this one is also connected with another 3 ohm in series, so 3 plus 3 it will be 6. So from this point to this point, here is 6 ohm, and also in the upper half another 6 ohm, so 6 and this 6 are in parallel, so it will be 3, and another 2 ohm are in connected in series with B point, so here is 2. Okay, and now lower half, if we go through this point, here is a 20 ohm. Okay, and here is this 20 ohm and this 20 ohm are connected in parallel. This 20 ohm or this 20 ohm is connected in parallel, so the equivalent resistance will be 10. Now this 5 also connected with 10 and this 5 also connected with 10, so the equivalent resistance of this circuit will be this portion, this lower half portion will be like this. The upper half at 10, the lower half is 5 plus 10 plus 5, so means 20, and lower half is also 20. So basically 20 and 10 ohm are in parallel, so the equivalent resistance 1 by R will be, for this one by R1, if we say it is R1, then 1 by 20 plus 1 by 20 plus 1 by 10, so it means 4 by 20 means 1 by 5, so this R1 will be 5. So here the equivalent resistance of this total portion is 5, so here it is 5. Now it is connected to this B point. So this 5 is connected to B. Now from this B point, see, a 5 ohm resistance is connected to this point. Let's say it is C. So 5 ohm resistance is connected, okay, with C. And this 15 ohm, this 15 ohm and this 15 ohm are in parallel. So three 15 ohm resistance are in parallel. So the equivalent resistance will be 5 ohm. Resistance will be 5 ohm. Okay. Now the equivalent circuit will become A point. It is 10. It is 2 plus 3 plus 3 plus 2, 10, and also the lower half is 5. So basically 2 10 ohm and 1 5 ohm are in parallel, and 2 5 ohm are in parallel in between B and C. So the equivalent resistance will be 5 by 2. Okay. Now for this portion, the A to B, between A to B, the equivalent resistance 1 by R2 will be 1 by 10 plus 1 by 10 plus 1 by 5. So it will be LCM 10, upper half is 4. So R2 will be 5 by 2. So the equivalent resistance of this circuit will be A point, it is 5 by 2, it is B point, and also 5 by 2 C. So finally 2 5 by 2 ohm resistance are connected in series. So the R equivalent will be 5 by 2 plus 5 by 2. So it is 5 ohm. So final answer is 5 ohm. So 5 ohm will be the equivalent resistance of this auto. Okay, tata. See you tomorrow again. Till then, goodbye.